lipids. So lipids make up a good chunk of our diet. A typical diet has about 50 grams of lipids per day. Most of that is in the form of triglycerides. So think about those 3 fatty acid tails and a solid glycerol backbone. And lipids have a unique problem in being digested and absorbed. They are non-polar. Remember, fats do not play nicely in aqueous environments. So they're not water soluble. And so this is a very special challenge that we see with lipids in order to get them broken down and absorbed across the stomach or even the intestines. And so what has to happen is they have to form these fat droplets. So with the help of lipases, lipases are being released from the pancreas, again, another component of the pancreatic digestive juices. So think about all those pancreatic, all those protein enzymes, as well as some of the fat enzymes. All of that is mixed together in that pancreatic juice that's released into the duodenum. And then lipase can only break down smaller fat droplets. So they can only act on the fat molecules that are near the periphery or the edge of that fat droplet. This is where bile salts come into play. So bile helps to increase the surface area, basically take that large fat droplet and break it down into much smaller fat droplets, a process that we call emulsification. And help with breaking down those fats to their smaller components, which are monoglycerides and fatty acids. Alrighty. Okay, so we've got lipase coming in first, breaking down those fat droplets to smaller components. And so they can be further broken down to be absorbed by the cell. And then bile salts are really helping to break up the large droplets into smaller droplets so that they can be further degraded by those lipases. So let's look at what bile salts are. They're basically synthesized in the liver. They're made from cholesterol. They are amphipathic in nature because they have this hydrophobic or non-polar region, but then they also have a few polar groups which make them amphipathic. So they can exist and interact with both aqueous environments because of this polar side and non-aqueous environments or fatty environments because of this hydrophobic side. And so what these bile salts do is they can sort of get in between that larger fat droplet and kind of break pieces away. This is a process we call emulsification or emulsifying, not to be confused with digestion, because this is not an enzymatic process. This is just mechanically separating that fat droplet into a little bit smaller droplet so that lipases can access all parts of that fat droplet and break that down to even smaller parts. Okay, and this is the importance of those bile salt, that bile that comes down from the liver, stored in the gallbladder, and then is released into the duodenum. Is it's really important in breaking down the fat so that they can be absorbed. This is why when you eat a large fatty meal, this is a stimulus for more bile to be released into the duodenum to kind of manage or handle the fat that's coming through. This is also why if you remove your gallbladder, you should not be eating a lot of fat in your diet, because it's going to come right out the other end because it cannot be absorbed if there aren't any bile salts to kind of to emulsify it into smaller pieces. And you get that sort of stomach cramps and other kind of symptoms as those fatty components are moving through the GI. Okay. So now we can work on those smaller droplets. So as we see here, we've got this large fat globule. These amphipathic bile salts kind of broke them down to more manageable fat droplets. And then now our pancreatic lipase can come in and start working on these smaller droplets because it can access all parts of the actual fatty component of this droplet. And it's going to break this down into monoglycerides and then also fatty acids, so free fatty acids. And this is how reabsorb fats into those epithelial cells. They must be in the smallest component, either monoglycerides or free fatty acids. So we cannot absorb triglycerides, and we certainly cannot absorb these larger fat droplets. Some of those fatty components can be organized into a micelle. And if you remember a micelle, we talked about this way back in Unit 1. It's basically this structure where we got the hydrophobic heads facing inwards and the hydrophilic tails facing outwards, and they kind of sequester this fat droplet. So some of these are packaged into micelles as a way to transport them around as well, but majority of them are converted into monoglycerides or fatty acids and absorbed into the cell and then further absorbed across the basolateral membrane. So basically the equilibrium that exists between micelles and free fatty acids or monoglycerides really depends on the action of lipases. And so that is going to be determined by how much fat is in your diet. That'll determine whether or not we're going to have most of that being stored as micelles and circulated that way, or most of that converted to monoglycerides and fatty acids and absorbed that way. That'll be dependent upon your diet and other things like that. Okay, so once we have these monoglycerides and fatty acids, now we can work on getting them into our epithelial cell. So they can be diffused right across the cell membrane. Remember, they are fatty in their makeup. So is our lipid bilayer, the cell membrane. And so they can move right across that membrane via simple diffusion. So this is just kind of summarizing that entire process. We had this large fat globule. Bile salts came and broke that down into a smaller fat droplet. Lipases acted on that smaller droplet and made it into even smaller components such as monoglycerides or fatty acids. And then there's an equilibrium between whether or not we're converting these to these monoglyceride and fatty acid components, or we're making these into micelles. Either way, they're going to get moved across the epithelial cell by simple diffusion. And when they are in the cell, we can then send them to the endoplasmic reticulum, so the smooth ER. They are recombined or repackaged, reassigned into triglycerides once again. And then those triglycerides will be sent to the Golgi apparatus, so another organelle within the cell. I like to compare the Golgi apparatus to like the post office. It's really important for repackaging, reassembling molecules and enzymes and such. And so we send these triglycerides to the Golgi apparatus. They're repackaged into these molecules called chylomicrons. And chylomicrons are then secreted via exocytosis from the cell into the lymphatic system. Okay, so here is a much more detailed view of that. We've got these smaller fatty components, fatty acids and monoglycerides, moving across the cell membrane. They go to the smooth endoplasmic reticulum, where they are recombined to form triglycerides once again. From the SER, they are then sent to the Golgi apparatus. They are repackaged into chylomicrons, and chylomicrons are one of our lipoprotein families. So basically, they're going to repackage this in a way that it can be exocytosed easily and make its way into the lymphatic capillary, which is called the lacteal. We kind of spoke about the lacteal last time. It is a capillary in the lymphatic system. And so this is how fats are absorbed. They make their way to the lymphatic system. And then we know that the lymphatic system eventually communicates to the venous system. And so that's how fats get into our general circulation. They do not go immediately into blood vessels. Okay? Alrighty. Now, what happens to those bile salts? Remember, bile salts are being released from the gallbladder, depending on the fat content in your meal. They are helping to break down the fats in the duodenum, but they make their way to the ileum, where they can be reabsorbed into the vasculature, into the capillaries, and then sent back to the liver via the portal circulation, where they can be recycled and repackaged to make more bile, which is again secreted and stored in the gallbladder. So we're going to recycle these bile salts via reabsorbing them in the terminal part of the intestines in the